All right, ladies and gentlemen, we've just finished chapter 2. We're heading on to chapter 3. Don't forget, pay attention to the readings in between the chapters. You never know if a question is going to come up on the test or on one of our class tests. You know, that is a pretty big hint right there. Let's head on to chapter 3, Ecosystem Ecology. The one thing I want to notate here is, don't forget, 2010, the Haiti earthquake triggered a tsunami. This was made worse by deforestation, and that's what this first part of this chapter is about. A couple of key things here is, could Haiti actually see a similar course of events that Easter Island saw? We know the mysterious disappearance of the civilization on Easter Island. Could Haiti follow in that footsteps, using all their resources, not be able to sustain their population? So the trees were cut down. This meant no roots. No roots means soil erodes. This triggers mudslides and etc. So the movement of energy. This is a quick review of biology. Remember, abiotic versus biotic factors. You combine those and you get an ecosystem. If it is healthy, the ecosystem services are intact. The one thing I noticed from reading this unit or this chapter is that, defining the boundaries of an ecosystem can be hard to determine unless it is a small ecosystem. They use this example of the cave ecosystem right here, where virtually nothing gets in or out of the cave, and that's how we can tell that the ecosystem, is small. We can tell the definite boundaries from the ecosystem. This goes on to do another review about abiotic and biotic factors, into photosynthesis. Make sure you guys know the equations for photosynthesis and cellular respiration. I also want you to think about how UV radiation affects photosynthesis. We can tell by looking at the equation how water and how carbon dioxide input affects cellular respiration. But what about UV radiation? How would the plants protect themselves if UV radiation has increased or decreased? And remember, there are multiple types of UV radiation. We have UVA, UVB, and UVC radiation. Same with cellular respiration, you guys. How would the animals react if we had different water, different sugar levels, different oxygen levels? How would these all be affected into cellular respiration? Remember, animals go through respiration, plants go through both. Other organisms also photosynthesize. That's why we use the key term of producers when we're talking about photosynthesis here. Know the difference between an energy pyramid and a food chain. Know examples of each type of organisms: producers, primary, secondary, and tertiary consumers, scavengers, detrivores, and decomposers. Know that this is a food web. Know that the arrow points where the energy flows. For example, the gazelle eats the grass, therefore the gazelle gets the energy. Also, don't forget that with this we have animals that can have multiple roles in an ecosystem. The lion has multiple roles in the ecosystem. It is a secondary consumer as well as a scavenger. It looks like the giraffe only has one role as a primary consumer. The hyena has multiple roles, so make sure you know that all these organisms, they can have multiple roles, and that's why food webs end up being so complex. So over here we talk about NPP and GPP, gross primary productivity versus net primary productivity. Gross primary productivity measures the total amount of solar energy that producers in a system capture through photosynthesis. Net is the energy captured minus what is respired by the producers, and this is only by the producers. Make sure you make note of that. The best way to explain this is that your GPP is like a paycheck. Your NPP, your net primary productivity, is like your paycheck minus the taxes, so it's what you take home. NPP equals GPP minus respiration, and that is the units for that are kilograms calorie per meter squared per day. Remember, those can change. We essentially have a mass, a unit of area, and a unit of time. So going back to energy, take note of this figure right here. Most producers only capture about 1% of the available solar radiation. That is not a lot of energy that comes in from that sun. Remember, the sun is our ultimate source of energy here on the planet. So going on to this one, we're talking about biomass. Biomass is the amount of energy in mass in an ecosystem at a particular time. It's not the rate of energy used. I want you guys to look up here to this chart, the net primary productivity chart. The highest is where warm water and solar energy are abundant, so we have our swamps and our marshes. A lot of people think that primary productivity is highest in the rainforest. If you look carefully at this chart, you can see that tropical rainforests are second, along with coral reefs, but you know, about 500 more calories per meters year per year is the swamp and the marshland. Going on to our ecological pyramids, we have our rule of 10%. Review that. Know how to do the calculations of this, again, without a calculator. That ends module 6. Make sure you try to do these review questions at the end. You never know if you'll see one of these questions on the AP test or on my quizzes and tests. Let's go into the movement of matter. This module focuses on all of the biogeochemical cycles that we have. And we do have a number of them. I know in biology, you're pretty much only used to the water, the carbon, the nitrogen, and maybe the phosphorus cycle as what you are familiar with. But we do have these macromolecules, calcium, magnesium, potassium, and sulfur, that also do cycle throughout the earth and cycle throughout organisms within the earth. Let's start off with the hydrologic, or the water cycle. Make sure you know the steps. Make sure you also know that they don't necessarily go in order. Here's another do the math. Make sure you do the math. Try these out. If you have any questions, let me know. And another important aspect of AP Environmental is looking at how human interactions affect these. So we want to look how human interactions and activities affect the water cycle. So everything from harvesting trees to irrigation for farmlands, all that kind of stuff are all how human interactions affect the water cycle. Let's go on to we got the carbon cycle right here. So remember, 20% of living organisms are made up of carbon. One thing I want to make sure you guys know is this word sink. A lot of time you'll hear me say a carbon sink. That sink's just another word for storage. A lot of our carbon sinks are found in our, number one, our ocean. Our ocean is a huge carbon sink. We also have forests and swamplands. Those are also a couple of different types of carbon sinks. Again, make sure you know the steps and how human activity impacts the carbon cycle. Remember, combustion of carbon, which is fossil fuels. This is an abiotic process. Fossil fuels should stay in the ground. When we use the fossil fuels for energy, we throw off the steady state of carbon recycling. Carbon dioxide is high in oceans. This is a problem because it decreases the pH, making it more acidic. Then it affects the organisms in the ocean. We have a lot of coral bleaching right now where the corals are dying off. We saw how increasing acidity by adding the acetic acid to our shell experiment affected our shells. Also, I want you guys to note we add 8 gigatons of carbon to the atmosphere annually. That's huge. 1 gigaton is 1 trillion kilograms. That's 1 followed by 12 zeros. That's a lot of carbon that we're adding to the atmosphere here. It's not a good thing. Okay, we're going to go on to the nitrogen cycle. This is a really important cycle. You need to know all the steps, and you need to know that nitrogen just does not have one path throughout its cycle. It can do many different paths throughout its cycle. The nitrogen even raises acidity in the ocean, which is lowering pH. So we need to make sure that we're controlling how much nitrogen we're releasing into our oceans and into our grounds, and then they leach into the oceans. Nitrogen is also the limiting nutrient for plant production. That's why we are so concerned with nitrogen. We want to make sure that we have enough nitrogen in our soils in order for plants to grow healthy so we can have a good food source. Right here, I want to make sure you guys note that most nitrogen is in the atmosphere. We can go through nitrogen fixation, which is nitrogen turning into ammonia and then going into ammonium. We have our nitrogen in our atmosphere. This is ammonia, this is ammonium. We can have 2 ways to fixate this nitrogen. We can have the biotic way of fixating this nitrogen by bacteria in our soil. We have fixation in our atmosphere that's caused by lightning, and then also fixation caused by fossil fuel combustion. Once again, I want to make sure you guys know that we have ammonium, NH4+, ammonium, and we have nitrates, NO3. Nitrates and nitrites can be used by organisms, by producers mainly. Ammonium cannot. All right, again, make sure you know the impacts, human impacts of nitrogen on the nitrogen cycle and on Earth. Let's go into the phosphorus cycle. The phosphorus cycle is extremely interesting to me. Make sure, again, you know all steps and the impacts on it. So we get our phosphate and our phosphorus primarily by mining. That mining, you know, the residue leaches off into the dirt and then goes into our water systems. Too much phosphate, PO4 3-, creates algal blooms. Then the algae die, decompose, they use the oxygen in the water, and then we have hypoxic or dead zones. Phosphate is a limiting nutrient in water ecosystems. If we have too much, it causes an increase of algal blooms, which causes hypoxia and dead zones. If we have too little, the algae doesn't bloom enough, and then we don't have enough oxygen in our water systems, which causes organisms to die off. One thing I want you to note here is that there is no gas component to the phosphorus cycle. If you notice here, there's no gas component. We have no phosphorus in our atmosphere. It's all primarily inside the earth. Eutrophication, these are our dead zones, like I said, caused by the algal bloom. The one thing that I found really interesting, which, you know, goes towards what we're trying to learn in this class, AP Environmental Science, is that phosphorus is used a lot in fertilizers. Also, it's used a lot in detergents. And I didn't know this because I do look very closely and try to buy all natural ingredients when I'm purchasing my chemicals I use in my house, but detergents used to have a lot of phosphorus in them. Most have been removed, but there are still many states that have phosphorus in their detergents, in their laundry detergents, and in their soaps for cleaning. Make sure you buy phosphate free. That's really important. So if your parents are looking, you know, to change up what kind of laundry detergent they're using, try to suggest maybe phosphate free. Helps the environment. So we have some more. We have our calcium, our magnesium, our potassium, and also our sulfur. These are all really important macronutrients. Know again how they are cycled through as well as how humans impact that cycle. Let's go on. So we are done with module 7. Remember, try to do the review questions at the end of each module. Let's go on to responses to disturbances. So we have, this module talks a lot about ecological balance and ecological disturbance. One thing I want to make sure you know is that ecological disturbances are both natural and anthropogenic. Guys, what does that word anthropogenic mean again? Okay, make sure you know examples of each of these. We then talk about the difference between resistance and resilience. Resistance is how much a disturbance can affect the flow of energy and matter, and resilience is the ability for it to go back to its original state. So going back on, we're going to talk a little bit about watersheds here. Okay, we're going to talk about watersheds. Where does our water come from? Where does it drain to? I'm wondering if anybody in the class knows this. So we get our water from a location. Where do we get it from? And after it's done here, how does it get eventually to the ocean? And what pathway does it take? So make sure you're reading through this, reading about watersheds. Okay. Then finally, this module ends talking about species diversity and how it is the highest for an area that is experiencing an intermediate disturbance or an intermediate disturbed area, and we get the intermediate disturbance hypothesis from this. I want you guys to make sure you're familiar with this hypothesis that states that an ecosystem experiencing intermediate levels of disturbance are more diverse than those that have a high or a low. So like I said, this is a hypothesis. It has not been proven yet. We'll see if it does ever get proven. And then look, we're at the end of module 8, which is the end of the chapter. Make sure you're reading these working towards sustainability. Okay, and then trying to do the chapter 3 review, which has your learning objectives revisited, your practice questions, and your practice FRQ. So we will go on to chapter 4 next. I hope this helped you guys out, and that's it for chapter 3.